Hey, today is day 9, AMI day 10. If you notice, this is the end of the AMI day 10 where you go online to print off. You now need to make sure that you've either printed it off days 11 through 15 or you've come up to school and gotten the new packet starting for tomorrow and the 4 days for next week. Today, you will need a writing utensil, a 4.3 acceleration and speed time graph worksheet. This is what it looks like at the very top. It should say AMI day 10, and it gives you, of course, the directions for the day. Or if you don't have the accessibility to print or the availability to come up to the school, that's fine too. If you've got your phone, if you've got a Kindle, if you've got a tablet of some sort or a computer at home, you can work these on a piece of paper. If you work them on a separate piece of paper, make sure top right-hand corner, write your name and PS, which is physical science, AMI day 10. And then you'll need a calculator. You can also use your calculator on your phone if you do not have a calculator like we have at school, nothing really fancy. The assignment for today is let me get this out of the way. Assignment for today is to read how to graph, this says to read how to graph motion position time. I did not change that. You're going to read how to find acceleration using speed time graphs. Read and complete the examples, which we're going to do together, and then your assignment is to complete numbers 1 through 7. Together, we're going to do number 1 and number 5. So in all actuality, you only have 5 to do on your own. So it's not like it's too much work. It's not very arduous. Pay attention to what we're about to go over. Hopefully, today's lesson won't take near as long as yesterday's lesson, because yesterday's lesson took quite a while. Okay, so we're looking at acceleration and time and speed graphs. I feel like that is over my face, or you can't see what it says. Okay, so acceleration and speed time graph. We need to go back into our memory box and remember about acceleration and what variables we have to use to find acceleration. And if you remember, acceleration is the rate of change in the speed of an object. If you don't remember that, that's okay. That's what we're going to go over right now real quick. So acceleration's equation is A equals the change of V, and that should be a little v. Sometimes my computer likes to capitalize things and it drives me crazy. That V stands for speed, T stands for time, A stands for acceleration. So acceleration equals the change in speed all over time. Not the change in time, just the time. And then also remember, V is speed, T is time. We can also look at this using a graph based off of slope, where slope is the change in y over the change in x, where the change in y is y sub 2 minus y sub 1. Change in x is x sub 2 minus x sub 1. All right, so let's look at this one real quick. Let's look and see how can we find acceleration based off of a linear, I keep on wanting to say regression, but to me it doesn't sound right, but off of a line or a linear, I'm going to say line and stop trying to confuse myself. So it tells us in our key that we've got line A that is a straight line, and then we have line B that is the dotted line. So we see that there are two objects that are but are, let's say, running the same path together. And object A, if we remember from yesterday, we could take the slope of that line and it will tell us what the acceleration is. And so if I want to, I can take this point here and this point here because they are intersecting the y and the x. This is the y and the x. This would be my first point. This would be my second point. And I could say I'm going to put MA, and that little sub A just means line A. Let me make that a capital A, that way there's not any confusion. So, slope sub A, that sub A is for the A of the first line. And we're going to equal, first before we do that, we've got to find our points. So, point 1 says that my X is a 1 and my Y is a 5. Point 2, it says that, I'm going to put little dots here so it doesn't look like it's multiplying to be distributed. My X is between the 1 and a 2, so it's a 1.5. And my Y is between the 5 and the 10, so I'm going to say that that is 5, 7. 5, 6, 7, 8. Ooh, that's a little difficult. That's not, let's say that it is, so between 5 and 10, it would have to be 7 and a half, right? So I add 2.5 to it, so 7.5, yes. Okay, so now this is my x1, this is my y1, this is my x2, this is my y2. So I'm now going to put in my 7.5 minus my 5, because it is doing my y2 minus y1, all over my x2, which is 1.5, because in parentheses, minus my 1, and that is going to equal 2.5 for my numerator and a 0.5 for my denominator. Because I am not very good at mental math, sometimes I like to think I am, but I'm not. I gotta go grab a calculator real quick. Divide by 2.5 divided by 0.5. And it says that it is 5 would be my acceleration. So acceleration, we're using miles per hour over hours. So this was miles per hour. This is hour. Travel distance of 5 miles. So we can also look at that and say that he went a total of 10 for my y. So I can also put that in here where he started at 0, so 10 minus 0, all over my time, and it took him 2 hours. So 10 over 2 equals 5. And that is also in, because it's miles per hour. Look at me. No, oh my goodness, Miss Little. Miles per hour. So it's actually M. Oh my goodness. Listen, even for me, it's been too long. It'd be 5 miles per hour squared. So it's per hour. This is per mile per hour squared. Yes. Woo! My brain. It's been too long. I've slept. Now let's do the second one. The second one is the line at the bottom. That's the dotted line. And I can pick 2 points. So I'm going to pick this one here. And I'm going to pick this one here. So as you can tell, there are 2 ways to find the acceleration. We can either use the slope of the line, which we did using change in y divided by change in x, or we can actually use the acceleration equation and just look at the line. Either way you look is fine. Just make sure that if you're not sure that your slope is correct, you're not sure your acceleration is correct, do the other equation just to double check yourself. So I have picked, this is my point 1. Ooh, let's do the green one. This is point 1. This is point 2. So for my first point, my y is on a 2. I'm sorry, my x is on a 2. My y is on a 5. For point 2, my x is intersects 3. My y is at the 7.5. So I can do the same thing I did up here. So if I say slope of b, I'm going to take my y sub 2, which is 7.5, subtract it by my y sub 1, which was 5, all over my x sub 2, which is 3, minus 2. So I have 2.5 in my numerator, 1 in my denominator, which equals 2.5 meters per hour squared. Let's do the acceleration, where a equals the change in speed. So it says that my speed, which is on my y-axis, which is my dependent variable, it said that he finished at 10 miles per hour. He started at 0, so 10 minus 0, all over my change in time. He finished at 4. And he started at 0, which equals 10 over 4, which is divisible by 2.5 meters per hour squared. Pretty simple. So if we look at this, looking at his acceleration, which one went faster? You said the first line, or line A, or runner A, he went faster because he was able to go 5 miles per hour compared to runner B, which is only able to go 2.5 miles per hour. So when we just look at a graph, we can tell that the graph that has the steeper line is going to have more acceleration compared to the line that is not near steep, and it's going to have less acceleration. Okay, so that's basically what today's lesson is. You got, I think, 3 examples just like this one. It should be fairly simple. There was one that tells you to find the line of 2. So if let's say I erase this, and it gives you just the first runner and then shows that the runner changes their acceleration. You define the acceleration of A and the acceleration of B, and then just add those together to find the final acceleration. But now we need to do a little bit more work on calculating total distance. I know that we did it yesterday, and I had several students who were still a little confused about it. And so let's look one more time at how to find a total distance using a speed versus time graph. Let's remind yourself that distance equals speed times time. Remember, if we took the handy dandy little triangle, and the top would be our distance, bottom 2 would be our speed and our time. We know that speed equals distance divided by time. If we rearrange that by putting our hand over the D, not crossing out but putting our hand over it, we say that D equals V times T. V means speed, T means time. Because we know that speed or distance equals speed over time, we can also look at that the area of a square is length times width, and the area of a triangle is length times width divided by 2. It's going to divide it by 2, and then we're going to take those distances and add them all up together. So in this graph, we have A, B, C, and D. And the person who wrote this example went on ahead and showed you how to break these up, break these boxes up. So the first box is broken where it's hours at 2. The second box, which is B, is broken at 3. But because there's not an area, I guess there would be, to find an area using I don't know, it's not a trapezoid. Do not listen to Miss Little on that. I'm not Mr. Little. I'm not 100% amazing at geometry, but I try my best. But I'm going ahead and I'm going to split this in 2 and make a triangle out of C. So I have a rectangle for A, a rectangle for B, and then my last area looks more like a square, but it can also be used as a rectangle because I think I have more. 1, 2, 3, 4, 5, 6, 7. I have one more block, so it is a rectangle and not a square because all 4 sides would be equal, and on D, 4 sides are not equal. Okay, I think my next one allows me to solve it. No, it does not. So we just need to solve. And so I look at the first one, and I say that A equals, and I look using the length times width because it's a square, or I'm going to use the speed times the distance. And in this one, it is, why did I change color? Its speed went from, well, it was at 5 the whole entire time. Let me double check my work through this just to make sure that I'm saying this correct. You should also be able to look at your piece of paper because it goes over this with you. Okay, so it's at 5. I'm going to multiply it by 2. Yes. Okay. So I'm at 5 miles per hour. I'm going to multiply that for the time that I was allotted, and it went for 2 hours. And this is supposed to be a sailboat. So 5 times 2 is 10. That's for A. Now let's look at B. B says that I go for at 5 miles per hour also. But for just 1 hour. So his acceleration here, that shouldn't be another one, it should just be 5. And then for C, and this is finding acceleration, and it'll end up finding the distance. So this is still going to be miles per hour squared. This is miles per hour squared. C, it's a triangle shape, and so we're going to use length times width divided by 2. And so its length, which is going to be its speed, is still at the 5. And its width is going to be from the 2 to the 3 also. So we have to put the 2 underneath it. So it's 5 times 1/2. So 5 times 1/2 equals a 2.5 per hour squared. And then D is another rectangle, so we're just going to use the length times width. And its speed at D went all the way up to, it says 8, so this is 5, 6, 7. I'm going to multiply it by its hours change. It went from 6 minus 3. So 6 minus 3 equals 3. So we'll multiply by the 3. So 7 times 3 is 21 miles per hour squared. And then I'm going to take that distance and add them all up. So A was 10, plus B is 5, plus C is 2.5, plus D is 21. The total distance at the acceleration of staying at 5 miles per hour for 2 hours, and then increasing to 7 miles per hour for an hour, and then staying at 7 miles per hour for the next 3 hours. It's going to be 10 plus 15. No. 10 plus 5 is 15 plus 2.5 plus 21 equals 38.5. And that is miles per hour per hour. Yep. That is miles per hour squared. Looking at this, that's just mile wise. My goodness, this is mile wise too. Because when I multiplied here, whoops, didn't mean to do that. When I multiplied here, I actually multiplied miles per hour times hour. When I did that, it canceled those out and just left me miles. So this should be 10 miles. This is 5 miles, this is 2.5 miles, and this is 21 miles. Teachers make mistakes, and I don't have too much pride to say that I never make mistakes, because I do. Okay, so now let's take those two examples and let's put them into, let's do number 1 together. Remember on number 1, we have to figure out what's the problem, what's it asking, and what's it to calculate acceleration. Quick reminder, we know that acceleration is the change in speed all over the change in time. And remember, when I'm saying change in speed, I'm saying speed 2 minus speed 1, then all over the time it took. And I know that I could also use the slope, or we're saying that slope equals the change in y, which is also y sub 2 minus y sub 1, all over the change in x, y should be in x sub 2, oh my word, minus x sub 1. Okay, so either one of those equations I could use. It doesn't matter which one you use. I'm going to use, because I know that it is a positive line, I'm going to use the acceleration one just because it's easier to use. So I can say that acceleration equals the change in speed. My ending speed was 15. My beginning speed was 0. So I can say 15 minus 0 was my change in speed. All over my time. We finished at 3 hours. We started at 0. So 3 minus 0. So it was 15 miles per hour all over 3 hours. 15 divided by 3 is going to be 5 miles per hour squared. Pretty simple. If you wanted to do it the other way and find the slope, you are more than willing to. Just make sure that you find 2 dots that intersect the y and the x axis. So if I said this was my first dot, it would be 1 was my x1, 5 would be my y1, where my second point, my x2 would be 2, and my y2 would be 10. And then you input it, these 2 points, for slope. And it should give you 5 miles per hour squared. Okay, so let's do and practice number 5. So go to your next page and look at number 5, or skip several lines on your paper and calculate the total distance for this graph. So our problem tells us to calculate total distance for this graph. Remember, what you know is that speed equals distance divided by time. That area for a square, no, for a rectangle is length times width, and area for a triangle is length times width divided by 2, and then to find the distance to the total is a plus b plus c plus d. And we're looking at acceleration. So remember, this is for, and I keep on putting square, this is for a rectangle, and this area is for a triangle. Okay, so first thing we do is I'm going to break up my graph into rectangles. My first line would go at the 20 axis. So this is rectangle A, this would be rectangle B, and this one's already broken off for me for rectangle C. From 30 minutes to 15 minutes, it means that he had a 0 distance. He didn't go anywhere. He stayed at his destination. So what he did is he traveled at 30 miles per hour for 20 minutes, increased his speed to 60 miles, it's meters per minute. I'm sorry, I didn't even look at my unit. Meters per minute, and was at 16 meters per minute for 10 minutes, and then came to a complete stop for 20 minutes, got back on his bike or whatever, picked his speed back up to 20 meters per minute for 10 more minutes. Okay, so we just want to know what his distance was. So to find his distance, and these are all rectangles, so we're just going to use area equals length times width. And so we're going to be looking at, remember, acceleration equals the change in v, or the change in t. So we can still assume that this is like length, and this one is going to be our width. So let's look. So for A, I say that my speed was at 30, and he was at 30 for 20 minutes. So the acceleration was 600 meters. Then he increased his speed to 60 at block B for 10 minutes. So he was going 600 meters. Or he had a distance of 600 meters. And then the last one, he of course stayed still for 20 minutes wherever he was visiting, maybe eating, I don't know, pimento cheese sandwich with some Lay's chips or dill pickle chips, whatever you guys like to eat. Increased to 20 meters per minute for 10 minutes, which equals 200 meters. So then I'm just going to add A plus B plus C, and so that is 600 meters plus 600 meters plus 200 meters equals, so 600, 600 is 1,200 plus 200 more, traveled for a distance of 14 meters. Okay. If you have questions, if you have concerns, if you're still confused on how to find the acceleration using the change in speed over time, or you don't understand how to look at the graphs and figure them out, watch this video one more time, call a friend, call me. I really don't mind to help you out, but I don't want to leave you and just say bye. I want to leave you with a good thought. And today's thought, anytime you come into class, I always have some kind of thought on the board for you to think about. And today, Dr. Seuss kind of came to my brain. And one of his quotes said, "Sometimes you will never know the value of a moment until it becomes a memory." Guys, we are in a moment in life. We're in a moment of life that we have never experienced before. And you have the ability to take this moment and make it something that you would never have this time to do again. Maybe in this moment, you ask mom when she's cooking dinner or dad if he's grilling the meat, "Hey, can I help you?" Or "Can we just talk?" Maybe in this moment, you might have a feud going on with your sibling and you just want to sit and just be kind to them or see how you can help them out. And they're probably going to be like, if you've been mean to them, they'll be like, "Oh, what you talking to me for? Why you are not my friend. We are not friends." But this can be that moment in life that you can change everything from here on out. Biggest change you need to do is to stay home. Don't go see your friends. Don't go see your grandparents. Don't go see your neighbor. You don't know where these people have been. Stay away from them. That is what is best at this moment in our lives. Call them on the phone. FaceTime them. Keep them protected, especially you younger guys who are not even really getting the coronavirus. Keep the ones that you love the most protected right now. Stay away from them. Your friends are going to be carrying this coronavirus and not even know that they have it, because that's just how it's affecting people. You don't even know you have it at a certain age, because it doesn't affect your respiratory system as bad as someone who's in their 40s or their 50s or their 60s or 70s or 80s. So make this moment valuable. Don't let it pass as a memory and just think, "Oh my gosh, all those AMI packets they had us do, that was just awful." Make it a moment that will last forever. All right. Have a great day. See you tomorrow.